Hello and welcome to Alcasan's virtual open house. My name is Miss Melanie. This is Mr. Wes. We are from the Scholastic Outreach Services team, and we are here today for an activity called Fireworks in a Jar, and it's on liquid density.
So first, let's reflect on the properties of oil and water. What are some of their characteristics? What happens when you combine oil and water? Do they mix and form a homogeneous solution, which is miscible? Or do they layer and form a heterogeneous solution, which is immiscible? Think about these questions as we conduct the experiment, and we'll go over our observations at the end. So for this activity, you will need cooking oil, a tablespoon, 12 to 16 ounce cup or glass jar, clear preferably so that you can see the experiment. Food coloring, 2 to 5 colors for a more dynamic effect, but 1 color will still work with the activity. And you will also need Pop Rocks for a more dramatic effect, but we'll use those at the end. So first we're going to add 2.5 tablespoons of cooking oil to our 3/4 filled jar with tap water. Now wait about 10 seconds for the liquids to settle. As the liquids settle, observe the properties. So, Ms. Melanie, would you consider this to be a miscible solution or immiscible?
Mr. West, I would consider this to be an immiscible solution because the oil layer stays on top and the water layer stays on the bottom.
Absolutely. So this is a heterogeneous immiscible solution because the liquids layer. So now we're going to add our food coloring and observe what happens. So what happened when we added the food coloring, Ms. Melody?
Mr. West, there's still some bubbles that are larger that are floating in the oil layer, but most of the watercolors sunk through the oil into the water, and now the water is more of an orange color because we've had yellow and red food color.
Absolutely. So would you say that the food coloring and the water mixed together?
I would say they did.
Absolutely. So because the food coloring is water-based, water molecules are cohesive and they're attracted to one another. So the water-based food coloring seeps through the oil to get to the water so that it can be with the other water molecules, and then it mixes. So now, is our solution miscible or immiscible?
Well, Mr. West, I think it's both.
I agree, it is both. So the food coloring mixes with the water to make a miscible solution, and it doesn't mix with the oil. It still layers. So you have the oil layered on the top, above the water, for an immiscible solution. So it is both. So we're going to conduct the same experiment this time using Pop Rocks for a little more dramatic effect. So we're going to add 2.5 cups of cooking oil to our 3/4 filled jar with tap water. We're going to allow the liquids to settle again for about 10 seconds before we add our Pop Rocks. That's enough time. I think we can have the Pop Rocks now.
Okay.
All right, is that our food coloring again? So now, not only do you have the fireworks display in colors, you also have the sound. Or it sounds like bacon cooking in the morning. So, Ms. Melanie, what's your observation based on what happened this time?
So I noticed a couple of different things in our jar. Number one, most of the food coloring sunk through the oil really quickly this time. Number two, the Pop Rocks are making bubbles that are sort of landing against the bottom of the oil, Mr. West?
Absolutely. So once again, we have both solutions, miscible and immiscible. And then we also have the addition of gases added by the pop rocks. So the carbon, it's actually moving through the water, but it's stopping at the bottom and it's not penetrating the oil. So you have small bubbles formed at the bottom of the oil, making like a moon dust kind of
Effect, right?
effect on the top, yes. Thank you. Thank you for joining us for our fireworks in a jar experiment. Please join us for more experiments like this one at alkasand.org.